Well, good afternoon or good morning, depending on which time zone you're in. We'll go ahead and get started with the webinar. I don't expect this will take the entire hour. If we have time, we can try doing a brief Q&A through the online chat feature of GoToMeeting. But if we aren't able to do that, you are welcome to send me an email if you have follow-up questions, and you can see my email addresses on screen. For those of you who don't know me, I am Greg Freeby, the Executive Director of the American Segmental Bridge Institute. I assumed those duties this past January when the previous director, Mr. Randy Cox, retired after 10 years with the Institute. Prior to coming to ASBE, I worked in the Bridge Division of the Texas Department of Transportation for nearly 32 years. In my last 7 years at TxDOT, I served as a state bridge engineer. I also served as the chair of the AASHTO T10 Concrete Technical Committee for the 3 years prior to my retirement. I'm currently a member of the TRB AFF 30 Standing Committee on Concrete Bridges. I just wanted to give folks who didn't know me an opportunity to understand who I was, and with that, I'll begin the rest of the presentation. So this is an outline of the presentation, what we're going to cover today. We're going to talk about who or what is ASBE, because I know not everybody online necessarily knows the answer to that. What to expect at the upcoming convention. This webinar is kind of intended for first-time attendees, but I do understand there are a lot of folks that are online that are probably participating out of curiosity, and that's fine. I hope you'll learn something today as well. And then we'll also talk about segmental bridges, just what exactly are segmental bridges, and we'll give you sort of a little introductory knowledge so maybe the convention won't be quite so foreign to you. So the American Segmental Bridge Institute was created in 1988 just to sort of identify that there was a need to organize a group for owners, designers, and contractors and suppliers to get together to advance the segmental bridge industry. The first convention was in San Diego in December of 1989, and this year we will be hosting our 31st annual convention in Orlando. So ASBE's mission really hasn't changed much since it was identified in an organizational meeting back in December of 1988. Back then it was just identified as a needs to be met, which today we more recognize as a mission statement. And I'll just read this to you. I'll try not to do that on most of the slides, but I think this bears, I can't sum it up any better to say, ASBE's mission is to advance, promote, and innovate segmental bridging technology, share the knowledge, educate stakeholders, build professional relationships, and increase the value of our infrastructure by providing sustainable solutions. ASBE further modernized with the creation of a strategic plan in 2014, which is in the process of being updated this year. And the original plan established 5 goals to fulfill the mission statement, and those 5 goals are going to be continuing forward even with our new revised plan. And for ASBE, the strategic plan is not just to check the box to say, oh, we have one of those. Rather, excuse me, it serves as a roadmap for the organization and its membership. It sets direction for the Institute over the next 10 years with 2-year, 5-year, and 10-year objectives and strategies for each goal area. As I mentioned earlier, ASBE is an organization comprised of owners, engineering consultants, material suppliers, and contractors. Currently, we have 73 organizational members, including 14 transportation agencies and 180 professional engineers. This slide here just sort of gives you an idea of what the composition of our membership currently is. Well, the strategic plan also established a new committee structure that aligned with the 5 goals. So we have a different committee kind of with primary responsibility for each one of those goals. Each committee has a chair and is overseen by an executive committee member to help facilitate communication between those committees. More about ASBE can be found on our website, including information about membership, events, publications, that kind of information. But we'll get into a little bit more of that. But again, I'd encourage you, the website is a ton of information. Training and seminars is something that that ASBE does regularly. We do grouting certification training. We do flexible filler certification training for the state of Florida, for Florida Department of Transportation, that is. We do a construction practices seminar. We just did one of those in August in Houston. I'll talk about that a little bit. And then, of course, the annual convention and committee meetings that are done as part of that convention. On grouting certification training, we have one coming up in April of 2020. It's on April 6th. It'll be in Austin. Online registration is already open for this training. We typically have a little over 100 people who participate in this training every year, the one in April. And then we have now made the training largely lecture and web-based, or video-based rather. So the training can be brought to you at for your project group or your state. We just ask that we have sort of a reasonable size group, 30, 40 people is a minimum, to be able to come out and do that training. And this training and certification is referenced in the current Post-Tensioning Institute specifications, and also a requirement by a lot of owners. ASBE also produces a number of publications. As you can see the list here, I won't read it all to you, but we do have a very active group of committees that are working on various publications, and I'll touch on some of these later. ASBE also contributes to Aspire, the concrete bridge magazine published quarterly. This magazine is hosted by the Precast Concrete Institute, but is comprised of a number of members who contribute not only financially but also content to this magazine. If you aren't currently subscribing to this free publication, I would encourage you to do so. It contains a wealth of knowledge on current activities related to concrete bridges. The online publication and back issues is available. You could just Google search Aspire Bridge Magazine and you'll be able to find it. So I mentioned another one of our publications, the Construction Practices Handbook. This one was just recently updated in July of 2019 and is freely available. So I would encourage you after the webinar, go to the ASBE website and you'll be able to find this publication. And again, I'm going to mention it more later. ASBE also routinely partners with other organizations in the bridge industry, including the Precast Prestressed Concrete Bridge Institute, the Post-Tensioning Institute, the National Concrete Bridge Council, Federal Highway Administration, and the American Association of State Highway and Transportation Officials, also commonly referred to as AASHTO. But we work in close concert with all of these organizations to help not only promote segmental bridges, but also to help promote concrete bridge technologies. So ultimately, what is ASBE? If you were to ask me, I would say ASBE is people. It's people working together in a common objective to make life a little better for those around you. And certainly the framework is segmental bridges, but ASBE members get involved in a whole array of concrete bridge technologies and complex bridge technologies that really provides a great forum for folks to interact, again, even beyond segmental bridges. So let's talk about what to expect at the convention. As you may know, we are meeting in Orlando November 5th and 6th. If you haven't already registered, you still can, but I would encourage you to do so as soon as possible. So let's just talk a little bit about the overall program, and then later I'll get into sort of talking about segmental bridges. We open the convention on Tuesday morning with an opening general session. This brings all of the convention attendees together to hear from our president, Patrick Malone, and also to get updates from our various working committees to understand what their latest activities are. New for this year, we're also going to be doing a case study in our opening general session on our showcase project, the Wekiva Bridge Project. We'll do a tour of that project then on Wednesday afternoon, but this is a good opportunity for all the conference attendees to see this really interesting project. The general session also includes topics on some of the latest issues that I think all attendees want to hear. Then at noon, we will take a break for an awards luncheon. I will strongly encourage everybody, not only because there's a meal, but also the awards presentations are always very interesting to see the projects that received awards. We do these every other year. And we have a really interesting slate of projects that were receiving awards this year. So then the afternoon on Tuesday after lunch, we continue in general session with more project case studies and other technical presentations that, again, I think will be of interest to all attendees. I just want to kind of note we have a presentation on the US 54 Canadian River Bridge project, which is New Mexico DOT's first cast-in-place segmental bridge that's under construction right now in Logan, New Mexico. And so it's a good opportunity to kind of see a project in its early construction stages and understand about the design as well. Wednesday morning then has us in breakout sessions. We have two parallel tracks, one on design and construction and the other on information modeling. And I know some folks may struggle to choose which ones to go to, so hopefully you're bringing a colleague and y'all can divide and conquer. Then after the mid-morning break, our breakout sessions continue with one session on international projects and one on inspection and construction. We'll then have a keynoted luncheon, and after the luncheon, the buses will depart for the Wekiva project tour, where we will wrap up then the convention wraps up with that project tour. So convention tips, which is one of the things that really was sort of my motivation for this webinar, was to kind of give you all some guidance or some thoughts about attendance, particularly as a first-time attendee. The first thing I would encourage you to do is come join us Monday evening from 5 to 6 in Fantasia Room EF. We'll be doing a little social gathering get-together where first-time attendees will have an opportunity to meet with ASBE leadership, including executive committee members and board members, and just sort of a get-to-know-you. We'll do some little icebreaker activities and get you an opportunity to have some names and faces that'll be familiar to you then as you move about the rest of the convention. So my other little tip is to be present, and I know that seems kind of odd, but I will say it's always a difficult thing when we go to conventions because we all have jobs back home that no doubt keep emailing you or calling you, and you're doing your best to try to stay connected with what's going on at the job back home. But I would encourage you to sort of unplug a little bit and stay engaged with the convention. Attend the technical sessions and even take advantage of the breaks. You know, a lot of people look at breaks as an opportunity to catch up on emails, but I would encourage you to use that time to meet other attendees. Reach out and say hello to others at the convention. I'll tell you, ASBE convention attendees and convention ASBE members are very interested in getting to know you. And so a simple, handshake gesture to, somebody that's maybe you've never met before, I think you'll find ASBE members very receptive to engaging in conversation with you. And along that lines, visit the exhibitors. We'll have an exhibit hall set up. Most of these exhibitors are also ASBE members. They aren't there to do a hard sell. They're not trying to sell you car insurance or some latest gadget. They're there to provide information on latest products and services in the marketplace. There's a lot to learn from our exhibitors. I'd also encourage you to participate in the project tour. A lot of people say, hey, I've already seen a segmental bridge, so I don't need to go. I can tell you I learned something at every tour I go to, and I think there would be almost unanimous confirmation of that statement, even from our long-time attendees and people with literally years in the industry. There's always something to be learned on a project tour. And then ask questions. I can tell you, it's okay to not know. And the attendees there, they don't know what you don't know. And historically, ASBE assumes a lot of knowledge on the part of attendees. I can tell you from my own personal experience, some of the early ASBE conventions I went to, I was rather intimidated. I seemed like I didn't have near the experience, but it's okay not to know. And again, ask questions, get to know these folks, and ask questions when the presenters do Q&A. It's a good opportunity. So I did just see something that popped up on the chat that I want to address, because somebody asked the question about PPE that we need for the tour, and the answer is bring sturdy shoes. That is, don't wear sandals or open-toed shoes. You don't need to bring safety boots, but a good sturdy pair of either dress shoes or athletic shoes. We will be providing safety vests and hard hats. There will be drinking water on the buses as well, so you'll pretty much be taken care of. And as far as PPE, that'll all be provided to the attendees: safety glasses, hard hats, and safety vests. So thank you for the chat on that one. That's good. So much of what you're going to see over the next several slides, I've pulled from our RSNH member Tim Berry's presentation that he did at our construction practices seminar that we hosted in Houston. So thank you to Tim for this content. And of course, I've appended it with some other things, but my intention here is to provide you with just sort of an overview of segmental bridges and perhaps get you at least an introduction, so that when you attend the convention, at least some of the concepts and terminologies will be a little familiar to you. And again, as I said earlier, even though I worked in Texas where the first precast segmental bridge was built, as you'll see later, I can tell you when I first attended an ASBE convention, I was a bit intimidated. I had no direct experience in segmental bridges, and I just felt like everybody around me was so knowledgeable. And the fact of the matter is, that's true. But it's okay, like I said earlier, it's okay not to know. And hopefully this presentation, the remainder of this presentation, will get you a little bit up to speed, so you won't be like me, feeling kind of lost. So the first precast segmental bridge in the U.S. is located on Park Road 22 between Corpus Christi and Padre Island, Texas, and it spans the Gulf Intercoastal Waterway. Built in '72, it had a very modest main span of 200 feet. The technology was brought to the Texas Department of Transportation in answer to a question, which was, how are we going to do all of these crossings across the Intercoastal Waterway using a structure that's very durable long-term in a marine environment? As it turns out, this bridge has actually performed very well, and we'll talk about that some more later, but the 2018 National Bridge Inspection data indicates that overall this structure is in satisfactory condition. And here's a view of one of the segments in the casting yard during construction. You might note over here on the left-hand side the large shear key in the web. In new structures today, you'll find these shear keys are more evenly distributed around the cross-section. So while segmental maybe hasn't changed a lot since it first came out, there's always these advances that are occurring even just within the design and construction of the structure. This is another view during construction. You can see here the precast segments were actually erected by barge-mounted cranes, and so they were delivered from the waterway below out of Corpus Christi. This is just a view of the parallel structures that were constructed simultaneously. Usually today, when you see parallel structures, they build one at a time in order to maintain traffic. But since we had an original crossing here that was a little causeway, there really wasn't the need to do a phased approach. So both structures were built simultaneously. And here's a view of the operations to the post-tensioning of the positive moment tendons. And this is something you won't see anymore. Not to say we don't have positive moment tendons, but we don't bring them up through the bridge deck like we did in this first generation detail. We sort of realize that having an end anchorage that's exposed up on top of the bridge deck is probably not a good idea from a long-term durability standpoint. So these end anchorages are now usually inside the box or at the end of the box. Having said that, I will tell you that when these connections were recently excavated, that is to say we removed concrete to get down and look at the end anchorages, they were actually found to be in really excellent condition. So again, while this isn't the current practice, we've improved. It still performed or is performing very well. And this is just another overall view of the structure. And as I mentioned, it's really performing very well, even though it's first generation materials and details for a segmental bridge. And to this day, segmental is often the preferred structure of choice for long span bridges over in a marine environment in Texas. The first cast in place segmental bridge in the U.S. was on Interstate 8 near San Diego, California. 450-foot spans and 440 feet off the canyon floor. So it provided a really good structural solution to a geometric problem. Unfortunately, I don't have construction photos of this structure to share with you, but I will tell you this is another bridge that, while it's first generation materials and techniques, it's actually performing very well. The 2018 inspection data indicates this bridge is in good condition. So I've given you examples of the first precast segmental bridge and the first cast in place, but now let's go into a little more detail on this particular bridge type. And I won't read this entire slide to you. In fact, I'll just pause for a minute and let you read it. And so we'll just take a break here for a second, let you read. So I think this last bullet probably best explains what is most often meant. If it's still a little fuzzy, I think as we move through the rest of the presentation, this will become clearer. But before we get into a lot of detail about the actual types, let's talk about sort of an overall about segmental bridges, and let's talk about some of the advantages. This first advantage listed here, reduced construction time, is one that sometimes gets overlooked, and depending on the site conditions and construction methods chosen, segmental can often be the fastest to build with regard to on-site construction time. Using precast elements can greatly reduce that on-site construction time, which sort of leads then to that next about increased safety. Because if you have less on-site construction time, that's less time for workers and the traveling public to be exposed to that risk, that is construction and traffic deviations. So we actually can do safer projects using segmental. We also have the opportunity for reduced traffic disruptions, again, depending on the particular project. There's opportunity to impede traffic less. A lot of segmental work can be done from on top, as you'll see later, which results in reducing those traffic disruptions and traffic control, which sort of then leads to that next thing, which is reduced cost. Everybody always wants to ask, well, what's a segmental bridge cost? And the answer is always, well, it depends. And what it depends upon a lot of times is the overall project schedule and traffic control. It's not just about a square foot or unit cost on a segmental project. They are usually become very different projects with regard to the traffic control and other aspects of the project in terms of on-site construction. Other advantages are achieved in the long-term performance of the structure. Longer spans and top-down construction methods can mean less environmental impact. As you'll see later, segmental bridges are often very aesthetic structures. In fact, it's not uncommon for communities, once they see segmental bridges, to actually request or even demand segmental bridges for solutions in their urban environments. Segmental also has improved quality control because it's often constructed either in precast segments or in individual segments, there's plenty of opportunity to get things right before you place the concrete and move on to the next segment. Any defects can be repaired sort of in a more localized region as opposed to an entire length of one span that has to maybe be addressed. Segmental bridges also have relatively low maintenance costs since they are typically not painted, nor do they usually include details that allow like birds to roost or debris to build up, or even allow de-icing agents, contaminants to infiltrate into the structure. So they are, I believe, a very low maintenance structure. And then oftentimes these structures are built using local labor and materials, which has an impact on the local economy. They're not typically fabricated in some shop thousands of miles away and then hauled to the site for erection by an out-of-town erection crew. They're usually done using local laborers with few experts brought in by the contractor who has experience in segmental construction. Segmental bridges also offer structural advantages, the first of which is redundancy. While segmental bridges are typically single-cell boxes, these structures are highly redundant due to the multiple post-tensioning tendons that carry the majority of the loads on the bridge, provides additional load paths. So probably the most significant advantage of segmentals, in my view, is their durability, which we'll talk about here in just a minute. So to assess durability, ASBE produces a nationwide durability survey, and that first survey was published in 1994, and the most recent was in 2012 by Mr. Brett Peelstick of Eisman and Russo. An updated survey is using the latest National Bridge Inventory data is actually in the works. We expect to get that hopefully published sometime in late 2020. But again, it's going to draw on the actual data in the National Bridge Inspection Database. This is information that is collected by the states and their engineering consultants. So some people have said, well, ASBE's got the opportunity to skew their survey, but I would counter that the survey is using data that is provided in the national database that ASBE has no ability to influence. So really, we just have to put the data up and draw our conclusions based on the data. So having said that, the last survey, Brett and his team looked at over 350 segmental bridges constructed at various times since the first one in Texas in 1972. And overall, they found an average condition rating of 6.9. This is on a scale of 1 to 9. So it's almost a 7, which this is regarded as good condition. That's really not surprising. You'll seldom see bridges rated as a 9 even when they're brand new. In fact, most inspectors will sway away from that, and an 8 or even a 7 is about as high as most inspectors will assign even a brand new structure. The data also indicates that the service life is expected to be well over 100 years. In fact, between the report in 1994 and the 2012 report, which is a nearly 20-year period, the average condition rating didn't change. The 98% of them were still in satisfactory or better condition. So they're all, the population is performing very well. The first precast segmental bridge is currently 45 years old. As I mentioned, it's in satisfactory condition. And the first cast in place segmental is 44 years old and is also in good condition. So even this early generation technology is doing very well. So just about everything you'll see kind of from here on, you can find in more detail in our Construction Practices Handbook. This is a free publication that can be downloaded from the ASBE website. We used to charge for it. The ASBE leadership made the decision that in order to get the information into the hands of the people who really need it, let's go ahead and make this a free publication. So it was just updated in July. If you go to our website, there's a simple information page you'll fill out, and then you'll be able to download a PDF. You can then take that PDF to a printer and print in either black and white or color. There are color illustrations and photos now. But it's a good opportunity. We're capturing some information about you just so that we, if we have to do an addendum or an update to the manual, we'll have contact information for you to be able to let you know that there's an update. So let's drill into segmental bridges in a little more detail, and let's start with a little terminology. The primary components of a segmental bridge include the segments themselves. You can see in this illustration the typical segment, the pier segment, and then the variable depth segment. Now, not all structure types have these three segment types, and in fact, some people will laughingly say there's no such thing as a typical segment because every segment is different. And that's, that can be true certainly in some of the construction that is done in urban areas where complex geometries are actually accommodated. But again, not all segmental bridges include all of these types, but those are the three sort of basic types. The pier segments also typically include a diaphragm. This diaphragm provides an anchorage location for the continuity tendons, and it also increases the rigidity of the box section. So that kind of leads to the continuity tendons, kind of leads to the next major component of segmental bridges, which is the post-tensioning, or PT as it's commonly referred to. It's a very integral part of segmental bridges. The typical PT includes cantilever tendons in the top, continuity tendons in the bottom, and then transverse tendons in the bridge deck. Other segmental components include shear keys. If you recall earlier, I pointed out that the first segmental bridge included just one large shear key in each web. Well, further research indicated that distributing shear keys throughout the structure gave us a better connection between segments. So now we have shear keys in the top slab, in the bottom slab, and then also distributed throughout the web. This diagram also gives you a little closer view of the location of the bottom continuity tendons, as well as the cantilever tendons, and then kind of a diagram showing you where the anchor blisters are, which provides anchorage for some of the post-tensioning tendons. Temporary post-tensioning bars are also used commonly to join segments prior to application of the permanent post-tensioning. So more terminology certainly can be found in the Construction Practices Handbook, and I would highly encourage you again to seek out that document. It's a wealth of knowledge, whether you're on the construction side, the design side, or even just the curiosity side. There's a lot to be learned from that handbook. So next we're going to talk about the segmental bridge construction techniques, or bridge types. First, we'll talk about the different techniques within precast segmental, which include span by span, and we'll talk about some of those construction techniques for span by span, balanced cantilever, and again, we'll talk about some of the various techniques associated with it. Progressive placement then, and incremental launching, two types that aren't very common, but I want to at least make you aware of them because I know we have at least one presentation during the convention talk about incremental launching. We'll also then talk about cast in place segmental and a couple types of techniques for constructing cast in place segmental, and then three other segmental types that sometimes get forgotten as being segmental bridges. There's cable stayed or extra dosed segmental bridges, segmental arches, and segmental precast substructures. So here's a table that gives you span ranges just to kind of familiarize yourself with some of the possibilities of the techniques. Now, these aren't hard limits. Obviously, somebody can always tweak these a little bit. But I will point out, you'll notice that the span limit, upper span limit for balanced cantilever cast in place is around 850 feet, something on that order, whereas precast, it's limited to more around 500 feet. And a lot of people ask, well, why can you go longer span in cast in place? And it's really not a limitation of the technology or the materials. It comes back to hauling and transporting of the precast segments. And more often, it's height limitations and weight limitations. Height limitations are, ironically, those segments are so deep they won't pass underneath many of our existing bridges. So that's where those just kind of give you an idea of where there was the reason for those limits. So in span-by-span construction, an entire span of precast segments is erected and becomes self-supporting before the next span is erected. Typically, a temporary erection truss is used for support while the segments are epoxy joined, and then the post-tensioning is stressed, at which point the span becomes self-supporting. In this view, you see a photograph of the span-by-span construction of the approach spans for the Corpus Christi Harbor Bridge, which is currently under construction. In this view, you see an overhead gantry, launching gantry, that is being used to support segments during construction. Once the post-tensioning is applied, then the gantry is advanced to the next span. Gantries can also be underslung or beneath the superstructure, as we see here. You can see that they're actually supporting underneath the wings of the segmental. And here's a little graphic that kind of describes this construction sequence. Most often, the trusses, as I mentioned, are support each segment underneath the wings or the bottom soffit. Although overhead erection trusses are also used as seen here. Of all the segmental bridge types, span by span are possibly the simplest and most often most cost effective. The span by span method can be very effectively applied to moderate span lengths up to around 170 feet, although this has been expanded to upwards of 180. The real advantage is a lot of the work occurs from on top, and this is really useful in those congested urban environments where access to the lower roadways is very limited. In fact, it is not uncommon that segments are even delivered from on top as construction goes, so that there's almost no disruption to the lower roadway. There are several variations on span-by-span construction. Entire spans for precast segments can be constructed on the ground or on barges and then lifted into position. It's a technique you don't often see in the United States. Asia in particular really makes use of this. This technique requires some really massive lifting equipment, as you can see, but it certainly can be done. This graphic shows that construction technique using a launching carrier. In this case, the fully precast span is delivered from on top. A launching carrier is used to haul and erect the segment. For each span, a support beam is used to provide a means to support the launching carrier around to the next span. Here we are. This is another variation on full span construction. In this case, the segment was delivered from a barge from below, and they're just using strand jacks to lift the completed span into position. So next we're going to talk about is precast balanced cantilever construction. And while that shares many of the features with precast segmental span-by-span construction, it is a distinct method with its own unique details and procedures. This technique is used when longer spans are needed, often in response to obstacles like rivers or highways that have limited ground access. Precast balanced cantilever spans are an elegant approach that minimizes the impact on the site and are often companions of span-by-span erection on long viaducts. That is to say, sometimes you'll have a combination within a structure of some spans that are constructed span by span, and others then that are constructed by balanced cantilever. And that continuity then allows for those longer spans. In this view, the photograph here, you'll see the segments are being placed using a launching gantry. And then next we'll take a look at a little graphic that shows you a little more illustration of this detail. In this view, you'll see erection progresses outwards from a central pier until adjacent cantilevers meet at midspan. Segment erection generally progresses in symmetric pairs with one segment of each pair secured to opposite ends of the previously completed structure. with post-tensioning bars. You can see here this kind of illustrates that we're adding a segment to each side, trying to keep that interior pier more or less balanced during construction. But as you might expect, it's never truly balanced, and those erection forces and stresses are absolutely critical in consideration during design. And an alternative then to the erection gantry is to use lifting frames. These are positively attached to the completed section, the previously completed section, and then used to lift the segments into place. And here's a view of segment lifters being used. I believe this was on the Dallas High Five project a few years ago. And so then here's again the familiar graphic I've been showing you that shows this method. On the right side, you will see the pier segments are typically placed using cranes. This little view right here, where they're placing with the cranes, the pier segments. And then the individual segments then could be placed using span lifters. Balanced cantilever can also be erected using cranes, and it's probably the fastest and most economical method, although that does depend on whether you have really good access from below as far as crane locations. You can see sort of here some of the attributes of erecting with cranes. Uses readily available equipment. There's no specialized gantries. You can usually use smaller erection crews. And this also allows you to construct on multiple fronts. And let me go to the next graphic that'll kind of give you an idea what I mean. In this illustration, you can see they're lifting segments with cranes on either side of this pier, and also could be working on other pier segments at the same time, which again can definitely speed up the construction time. So progressive placement. Now, when the placement of ground-based cranes or activities beneath a structure are limited, then progressive placement becomes attractive. Here you see a structure going up on the Blue Ridge Parkway. While this method is very attractive from an environmental standpoint, it is also one of the most expensive methods of construction, as you might expect, because your headings or your locations that you're able to work are limited by your access from above, and so there may be limited haul roads built below to build substructure. Pretty much everything is built from on top, and again, expensive, yes, but it is absolutely a great solution when environmental constraints are such that we're trying to limit the impact on the environment as they were when they constructed this particular bridge on the Blue Ridge Parkway. Incremental launching is another method where if we have restricted site access to the lower roadway, it's a good solution. Constructing incrementally means you're going to build each segment at the end, and I'll have an illustration here I'll show you in a minute, but you can see this little almost looks like a tent-like structure at the end. That's where each segment is being constructed. Once the concrete has reached its specified strength, then it's advanced forward, launching then the segment out onto the spans. And usually there's a launching nose that helps guide the entire structure across each pier segment. Incremental launching combines the advantages of cast in place and precast in a way. They're relatively compact to build. They don't really interfere with the obstacles the bridge needs to pass over, whether it's a waterway or lower roadways. The casting yard required is small, relatively speaking, because it's all right there at the end of the structure. Other advantages include more streamlined construction and labor. You have a labor crew that's basically largely doing the same operations over and over and over, so they get very good at what they're doing. It's relatively inexpensive as far as this kind of method in terms of if you're having restrictions on the lower roadway. So cast in place segmental balanced cantilever using form travelers. In basic terms, cast-in-place balanced cantilever construction refers to the process where segments are progressively cast on site at their final position in the structure. This differs from precast, where the segments are prefabricated at a casting plant, either on site or a remote facility, and then transported to the project site and erected as a complete unit in the final position. With cast-in-place construction, the segments are built in place in progressive increments, one segment at a time, usually one on each side of the pier, again, to try to keep the pier balanced during construction. This removes the manufacturing from the controlled environment of a casting yard to the superstructure itself, but there's still plenty of opportunity to ensure quality control because, again, you're just building one segment at a time. The form traveler supports the closure form and is used to jack against to align the cantilever tips here when you're doing the final closure pour. As you might expect, geometry control and deflection predictions measured during construction are critical. But again, there's techniques that can be used to bring those cantilever tips into line, and usually a well-executed project, they're only off by a few inches at most during construction. So it seems like that old cartoon graphic where the two bridges don't line up, but more often than not, they're very accurate in their deflection predictions, and therefore good geometry control will make sure those cantilevers line up. So I mentioned earlier there's a couple segmental bridge types that sort of often get forgotten as being segmental. One is cable stayed, which is illustrated in the left-hand side picture of the Sunshine Skyway, and then the other is an extra dosed, which is a variation on cable stayed. Again, the illustration here on the right is the Q Bridge, New Haven, Connecticut. Cable stay bridges have been increasingly successful for spans as short as 300 feet, as long as 3,600 feet, using multiple cables to ease erection, reduce the weight of the bridge decks. In addition, cable stayed structures can resist dynamic effects due to the loss of a stay cable. So that's usually built into the design. There's a criteria about being able to lose stay cables either just as part of routine maintenance or vandalism or an incident, an accident that happens. These structures are highly indeterminate, as you might expect, and so those construction phases are a whole lot more critical than for conventional bridges. How closely the final constructed state of stresses in the structure matches the design intent depends greatly on the accuracy of construction. And so this is where, much like other segmental types, the engineer is in the loop during construction. It's not just kind of hand off to the contractor, go build a bridge. There's very much a back and forth between engineer and contractor during construction to ensure that the bridge is being built properly. And also then precast segmental arches, not very common. You will come across these as precast segmental arches. This is a view of the most recently completed Mike O'Callahan, Pat Tillman Memorial Bridge, or they're also known as the Hoover Dam Bypass Bridge, again, built from precast segmental components. Precast segmental substructure, another part of segmental design that maybe sometimes doesn't get recognized as segmental. It's not uncommon to see when you have a segmental superstructure, the contractor sometimes even elects then to do precast segmental substructure. At our convention in November, we will have a presentation to talk about the project going on in Birmingham, Alabama, where the contractor elected to use not only precast superstructure elements, but precast substructure elements. The first bridge in the U.S. to use precast segmental columns is generally acknowledged to be the 7 Mile Bridge in the Florida Keys, built in 1982. And since then, there's been dozens of bridges constructed using this technique. It really helps in terms of construction schedule, economy, and even durability, because these segments are then post-tension vertically which most column sections in bridge construction today are just monolithic cast in place with just mild reinforcement. So typically in precast segmental substructures, you have the advantage of post-tensioning in the vertical direction. This is a view of precast segmental columns built on US 183 project here in Austin, Texas. These were hollow hexagonal shapes that you saw on the previous slide, and this just gives you a view of them in place. Precast segmental substructure can also include rectangular piers and pier caps as shown here. The use of precast segmental substructures provides many of the same benefits of precast superstructures in terms of increased quality and increased speed of construction. So with that, how are we doing on time? We have about 5 minutes left. So just as a quick wrap up, so today we talked about ASBE in general, so hopefully you have a little understanding of who the American Segmental Bridge Institute is and some of the activities we get involved in. We also talked about the convention that's coming up, and again, I would encourage you all, if you haven't or you're not planning to attend, I'd encourage you, there's still time to register, so if you haven't signed up to attend, please do. And also we talked about sort of, as if you are attending as a first-time attendee, sort of some strategies to make the convention go well for you. And again, I would encourage you to come to that initial icebreaker get-together we're doing in the evening to sort of meet and greet some of the first-time attendees. And then I also talked then about segmental construction in general, and hopefully you're armed with a little more information about what segmental construction looks like and what some of the terminology is. So maybe you'll have a little better experience at the convention, and as the presentations come up, you'll see things that maybe now you're a little more familiar with. So with that, I thank you. I will take a shot at looking at the chat if somebody wants to send in a chat message. Again, little shout out to Tim Berry, my colleague at RSNH, for helping me in terms of providing some information for the presentation. If you have any questions, something comes up after this presentation, you're certainly welcome to contact me. You can see my email address there on screen. Welcome any feedback, even just about the presentation in general. So with that, question, do we have to register for the site tour separately, or are we already good to go? The site tour is actually a separate charge. I believe it's $100 where we have to charge because of the expense of renting buses and to get out to the site. If you're from a DOT though, that fee is waived. So but you do need to register for the tour separately. You can do that either through the website or even on site during the convention if that's what you choose to do. So thank you for that question. Anything else? All right. Well, I appreciate everybody's time this morning or this afternoon, depending on your time zone. And with that, I will end the webinar and again say thank you, appreciate your time, and have a good day.